So let's begin this journey by looking at knowledge and understanding. Knowledge and understanding are really the prerequisites in order to effectively use any tool to solve a problem. Just think about it. It doesn't matter how many tools we have, if we don't understand or know anything about the problem at hand, we cannot use these tools. Just like a computer is completely useless to us as engineers if we don't know the actual fundamental engineering problem at hand. Now, although computers are highly efficient at solving complex mathematical problems, if we don't know anything about that problem, we cannot interpret the results from them. So how do we get this understanding? Well, scientists and engineers normally carry out a set of experiments on a particular problem. From these experiments, we extract data, we analyze this data, and after a series of repeated experiments, we may then start to see repeated aspects emerging from the dataset. We can then use these repeated aspects to derive fundamental laws that build on our theoretical understanding. So let's look at a problem solving as a two-pronged approach. On the one side, we use empirical methods to look for patterns in the data, and on the other side, we use or construct theoretical understanding in order to better improve our general knowledge or understanding of the problem at hand. Now, empirical means and theoretical methods are strongly coupled because the new measurements that we take will update our theory or theoretical knowledge of a particular problem. And then this new theory can in turn be used to update how we measure or observe the particular fundamental properties of the problem. For example, Newton never knew why the apple fell from the tree until he proposed his theory on gravity. He then took measurements of mass and distance, etc., to improve his theory on gravity. 100 years later or so, after many measurements, scientific measurements, Einstein then refined the theory on gravity, and we are still making measurements to date that attempt to refine this theory. Therefore, we can use empirical methods and theoretical understanding to form the framework to solve complex mathematical problems and develop engineering solutions for them. In our next video, we're going to look at what a mathematical model is and how we can construct one.